In my last speech, we talked a bit about magnets and why they're so important to everyday life. So this week, let's go a little bit more in depth into that, talk about how we use magnets and how it all works. So to get right into it, I did a quick teardown on a small DC motor. I bought it from Radio Shack a couple years ago. It's about 500 RPM, I believe. So I did a quick teardown on it, and as you see, I have two pieces of it, the shaft of it and then the casing. So to just show how it works, if you can see in there, there's two little plates on the sides, and those are both magnetic. As you can see, the shaft here is it's made of steel, so it's magnetic too. So we have that, and the shaft fits right in there, in between those two plates. Fits nice and snug. And then the shaft itself has an interesting construction. As you can see, it's three copper coils in there, and they've got plates on the side that just keep it off the sides of the casing. And then down here at the very bottom, you see these little prongs that stick out. These prongs are where the electricity goes into the motor itself. The back of the casing had two headers where you would be able to connect your battery or whatever to power the motor and make it run. And essentially, the way that it works is that the power goes into, let's just say that it goes into this coil right here, this first coil. So then it goes into that coil, and it actually charges, it goes into the prong, and it charges the coil, and it causes the coil to become magnetic, because copper isn't by itself magnetic. It's not magnetic until it has a charge. So it becomes a temporary magnet, and it turns inside of the casing towards another magnet of the same polarity, or of the opposite polarity. And so then, by the time that it's turned, the next header, the next little prong, has turned around and is being charged, and so it charges the next coil. And the previous coil isn't being charged anymore, so it's not attracted. So this one gets attracted to that piece in the casing yet again. So it basically just makes the whole thing inside, one by one, the coils charge and discharge, and it causes them to turn towards the magnetic plates inside. It causes the whole thing to turn. The really cool thing about electrical engineering is that a lot of things work in reverse. So when we do this in reverse, and you spin the magnet, or spin the motor without putting any charge into it, it actually outputs a charge. So that would be how generators work. So now imagine, let's say a big shaft just like this. It's probably about the size of the room that you're in, spinning thousands of times per minute. That's how your energy is being generated. Another cool thing about generators is that they don't really make energy. They just take it from other places and turn it into the form that we need. So for instance, the generator that's probably powering the house that you live in right now is powered probably by uranium or natural gas. And so those are both high energy substances, and when they're expended, the gasoline by combustion, being burned, or the uranium by decay, it's generating energy that is then being used to push the shaft around in circles and generate that electricity. So the generator isn't making the electricity, it's more like it's transforming the electricity into, or transforming the energy from one form into another so that we can use it. So that's just a basic lesson in mechanical and electrical engineering, how generators and motors work. So, hope you enjoyed.